Good morning, this is your Stats Sensei, Mr. Spensei, and this is a pre-quiz on z-intervals, and we are going to be working on a scenario too much time. So NEISD runs a summer youth program and has more than 6,000 high school students participating. That 6,000 represents our population. You take a simple random sample, that's going to be important because simple random sample is one of our conditions of 35 students. That N is our sample size, so N is 35, and record their one-way commute time to their job site. The sample mean, which is their X bar, the sample mean, is 18.4. So the sample mean is 18.4. That's basically the average time is taking them. And assumes the population standard deviation is 6.0. Because it's the population, this we can use a Z. All right. If it were not the population, we'd have to use something else, but we'll learn about that later. Construct a 93% confidence interval for the mean. So we're trying to estimate the population mean commute time of all such programs. We have the sample mean and we're trying to estimate the population mean. Okay, so the very first thing we have to do is write down our formula. And our formula is simply x bar plus or minus z star standard deviation divided by square root of n. Well, kind of the nice thing is we already have x bar, we already have n, and we already have the population standard deviation. What we're missing is z star. So let's go ahead and write down, fill that information out on our table. We have sample mean of 18.4, sample size of 35, population standard deviation of 6, and the confidence level they gave us was 93%. And remember, always take percents and divide it by 100. The next thing we need to do is we need to estimate our z star. We need to calculate z star, and the way we do that is basically all z scores are centered on 0. And in this case, we want a 0.93. And we're looking for the upper and the lower. And really all we care about is I labeled those wrong, excuse me, the lower and the upper. And really, we just need the positive value. So really all we want is the upper. And we're going to go second vars. And we're going to drop down to inverse norm. And we want a 93, so 0.93. Mean is 0 standard deviation. And we have center on this calculator, so we just select center. And we get 1.8119. We need 4 decimal places. And so it is, Z star is 1.8119. At this point, we can go ahead and plug into this formula because we have everything. So with that said, here's my population mean. Then we have our Z star. Then we have our population standard deviation. I should have said sample mean, by the way. And then the last thing we have is our sample size. So there we have everything in. Okay, so let's go ahead and draw a picture of what we're actually looking for. I drew one for the Z. What we're actually looking for is this lower bound and this upper bound, and we're centered on our X bar. Originally, we were centered on our Z, and our Z had a mean of 0, and 1.8119 is our upper, and negative 1.8119 was our lower, and that's what we got on our calculator. So the inference procedure. Well, this is a one sample Z interval. So one sample Z interval, and now we need to calculate that. Well, how did I do that? Well, I went to stat test. I have all sorts of things popping up on my computer. I don't understand why. Stat test, and we're going to not, we don't want Z test. We want Z interval because we're doing a confidence interval. And we want stats highlighted because we didn't put a list of data. And now we need to start inputting our information. Well, the very first thing it asks for is the population standard deviation, which is 6. Then it asks for our X bar, which is 18.4. Then it asks for our sample size, which in this case was 35. And we wanted a confidence level of 0.93. And we calculate, and there it is, 16.562 to 20.038. Now, please remember, this is my lower bound, and this is my upper bound, or this is x1, and this is x2. The next thing we need to do is define our parameter. Let mu equal the true population mean. This will always be that. This is our sentence stem. We will always have this part right here. I'm going to highlight that in yellow. This will be an always. And what do we care about from this problem? Commute time of all NEISD program participants. It's super important that you do this really well because we're going to use this multiple times. Now we need to address our conditions. The first condition, random sample. Oh, they told us the random sample of 35 and that was given to us. So we can go ahead and check that off. The next thing, we need to make sure that it's not too big. And we go, well, our sample size was 35. We always multiply it by 10. 35 times 10 is 350. And that's less than 6,000. So N is less than 10% of the population. Now you don't need to write that, but there it is. The next thing, we need to make sure it's big enough. They didn't tell us it was normal. In order to use this, either the underlying distribution has to be normal or our sample size has to be 35 or larger. In this case, 35 is greater than 30, and this can be a greater than or equal to sign. And so it's normal by central limit theorem. So not too big, but big enough. All right, not too big, but big enough. Finally, our conclusion. We are, well, there's our confidence level, 93% confident that the true population mean commute time for all NEISD program participants lie within this interval. Now, I want to point something out to you. Earlier, I said this parameter was super important. Well, look, guess what? Beginning right here, true population mean commute time of all NEISD program participants, that came straight from the parameter. So this part right here is the parameter. You've already written it once. You just need to write it again. Lies within our interval. Well, our interval came from right there. The next one, the meaning of the confidence level. In repeated sampling, we expect this method to capture the true population mean commute time of all NEISD program participants 93% of the time. Guess what? This right here, that's the definition of the parameter. So basically, this part right here, we're writing 3 different times. So it's super important you do a really good job defining your parameter because you're going to need it 3 different times. Okay, I hope this helped, and I look forward to seeing you on the next one. Thank you.